All right, welcome back, everyone. Just give me a second to get started here. So I've just opened up the week 4 section on Canvas. You can pull down this slide deck that we're going to be doing today, as well as files in order to follow along if you want. Okay. So just give me a second. We're already recording, just so everybody knows. Okay. Not that much to say since I only saw you guys a couple hours ago. I just got one of the from the same order that I ordered my disk detainer lockpicks. I got one of the packages that was not a lockpick today. So hopefully that means the rest of my stuff is on its way. And I'm not being arrested or anything. All right. Okay, put the chat window up. Okay, so we have the obligatory XKCD cartoon when talking about SQL injection. Let's get started. So I realize we have people from various technical backgrounds in this course, so I'm going to start from the beginning, but I will be moving rather quickly. So do try and follow along. So any reasonably sophisticated web application is going to need data from somewhere. And this can be anything from items in your shopping cart to usernames and passwords, accounts payable, accounts receivable. And the most common way to store all of these things is in a database. And a database is simply a collected group of data. So data that all has a specific purpose. So early on in software development, many programming languages actually had special extensions to work with databases. If I worked on SQL or in one of the early versions of Oracle when I was, I think when I was 17, I worked for the Ministry of Education, the School Board Services Unit. And so I got to work on their VAX 11780 machines, which is a mini computer. And in order to put database code in our code, you had to have these special commands that were in your code, and then you had to run your code through a pre-compiler, and then that would eventually run through the compiler. So today, though, we have a common way, although this is changing, for web applications to interact with the database through a programming language called SQL. Some people might cringe at calling it a programming language. Generally, the standard for considering something a programming language or not is whether or not it meets a piece of criteria called being Turing complete. Something that's Turing complete means that it can perform all the operations that a Turing machine can do. And you can Google what that is. But this is a hypothetical device, a Turing machine. And by use of this standard, we know that every programming language could, in theory, implement any other programming language. And we definitely do this. For example, C++ was written in C. Anyway. Or the first C++ compilers. Actually, the very first C++ compilers were written as compilers that converted C++ into C. And then you ran a regular compiler after that. Today, with LLVM, anybody who follows the compiler scene knows that we have very strong optimizers that do a lot of really technical and amazing stuff. Anyway, so we have this language called SQL, and SQL acts as a standard way to manipulate data in databases. Databases and just about any kind of data store really has four main ways to manipulate data. It's to create data, so you add something to the database, read, to take data out of the database and look at it, update it, change data that exists in the database, and delete data, so remove it from the database. And as you can see how I've lined these up here, these all refer to an acronym which we call CRUD. So databases store data in what are known as sets of rows and columns, which you can think of like a spreadsheet. The columns, or fields as they're sometimes called, represent the specific qualities we are storing. So if we have something that we're talking about, like a person, right, we could talk about their age. If we have an object, like something you're selling in a store, you could talk about its price and description. These are the qualities of something, and these represent the columns. And then the rows are the values for a specific item. So what is the age of a specific student? What is the price of a specific item? And as you can see here in the illustration, we've got student ID, student name, student major, student email, and as the different qualities we're keeping track of, and then 4 different records representing 4 different unique students. The rows and columns about a specific kind of thing, students, items, cars, are put together into a structure which we call a table. So this grid of rows and columns is referred to as a table. And these next few slides will discuss how SQL can be used to access data from a table. And it's worth pointing out that a programming language like PHP still needs a way to send SQL to a particular database, but we'll talk about that in a little bit. Okay. So to read information from a database, we use an SQL command known as select. To make it function, we provide it the name of the table that we are working on, as well as the columns we want to see. And we can even provide some filtering information through what's called a where clause. We can also use and or. So here, this up here is a table, right, that has 3 records in it. And we can use select, and we give the columns that we want, select names, comma, age. You can also replace this with an asterisk, which means select all the columns and then the table. When we give the information like this, it takes those 2 columns and takes all the data from people. But if we were to add a where clause, right, that would allow us to filter this data. For example, we could look at only the people who have an age greater than 25. And that would only produce Shaoli and Sarah Sims. So, and you could add further qualifications by adding something like an and. You could say where the age is greater than 25 and their name is equal to Shaoli, for example, in which case you'd only get 1 record back. All right, the next thing we're going to do is talk about how to put data into the database. And this uses the insert command. All you need to do is provide the columns that you're going to populate, the values that you're going to put into them, and the table that you want to put it into. So here's our table to start up here. Here's our command, insert into, and we give the table name people. So the name of this table up here is people. We give it the columns we're going to populate, names, comma, age, and then we get the values, Itman and 127, which is how old Itman would be today. Anybody who follows martial arts or martial arts movies knows Ip Man was one of the people who popularized Wing Chun, which is a martial art that I study. I studied under one of his direct disciples. But yeah. So once we run this command, the table will get changed and the data that we've provided gets inserted. Okay, moving on. Update. So if we want to change data in the database, we use this command called update. So this is different than insert because we are altering the content of data that's pre-existing. Now, the interesting thing about update is we can actually update just a specific portion of a row rather than the entirety of it. And the way we do that is we provide the command update, we give it the table name, and then we give it the set command and we give it a field name or a column name, and then we give it the value that we want to set it to. And then we can give it a condition and say like where age is less than 35. What this will do is then apply this rule altering the records to every row that meets this criteria. So in this case, we have changed Larry Smith and Xiao Li into their age to 20. Okay. Delete. Delete is pretty straightforward. It lets you remove data from the table. You can use a where clause to provide a condition. In terms of adding either delete or update or select, you can your where clause can be accompanied by an and or to increase the number of conditions that you're going to require the data to comply to. You can delete as many or as few rows as you want. Many databases will allow you to simply say delete people, in which case it will delete every record in that table, but the table would still exist. If you actually want to get rid of a table, use actually a different command, which is drop. We're not going to be covering all the different SQL commands in very much detail here because there's quite a lot, and I don't really want to teach a course in database theory. The point here is to give you an idea about some simple pieces of SQL that we can use to compromise systems. Someone asked me privately, is it mandatory to use clauses in the delete command? I think I just answered their question. Generally speaking, no, as part of standard SQL. You can type delete people and that will get rid of every element in the database, or every element in the table, but the table will still exist. Okay, so how do we move this into PHP? Well, because a database can exist on a different computer than your web application, and because a single computer can actually host dozens of databases, we need to provide PHP a little bit more information than we give SQL. The first bit we need is the type of database it is. In the case of our turnkey Linux system, it's MySQL. You will see in your system that it's called MariaDB. This is a branch or a version of MySQL that has been broken off from the main branch for various reasons. After that, we need the database name and an IP address on the server for the server it's located on. If it's on the same machine that your web application is on, you can often use the term localhost instead of the actual IP, or you can use the IP address of 127.0.0.1. That's equivalent to localhost. Okay, so we've just populated a string here. This is actually doing anything. This is just populating a string. And the string contains MySQL to say that this is the kind of database, a colon, the database name, which we're going to call my database, a semicolon, a host parameter, and the IP address. And this is all just a simple string. We're also going to say that there's a user and password. In databases, the actual databases themselves have in almost all cases, their own authentication stack, meaning that a database user and password is different than a user and password for the system that the database is running on. So when you log into your Linux box, you might use the account name root and the password for root. If you were to log into the database that's being hosted on that, it would have a root password, and that root password would be different than, or you could set it the same, but it's not necessarily the same as the root password for the login for the system itself. Does that make sense? Okay. Yes. So when you set up your turnkey Linux system, you should have set up a password for adminder and root when you created your the thing during the boot sequence. It should have asked you for that. You can create new users on your own from the adminer console. Adminer is how you manage the database portion of your turnkey Linux system, as opposed to the administration shell that we've been using to upload and download files. It's located at whatever your server's IP is, :12322. You will also see this URL when you boot your turnkey Linux machine. It will show up in the console. Finally, we take all that information and we tell PHP we want to create a connection to do this to this database. We do this by using PDO. This is a somewhat new, well, I guess it's probably no more than, it's probably about 20 years old now. This is the PHP data objects interface. There are other ways that PHP had for handling different databases, in which case they had specific functions to connect to each type of database. Like PHP had different functions than Postgres did, which is another database. But because this all got really complicated, they replaced it all with something called PDO. PDO returns a handle similar to the way fopen does, and we can use this to call other functions. So as you can see down here, we take all these strings and we pass it into this PDO function, and we give it the DSN, which is this big string, the database user, and the database password. We also use this word new here. I'm not going to go into a lot of detail here because people don't have necessarily have a lot of coding background. But new is something that's used within object-oriented programming. It just basically says that there is a kind of a variable type known as an object, and we're asking for a new one. And the way you can think of it in your head is we're asking for a new connection to the database. And it stores that in a variable here. Now this variable actually becomes the thing we do work with, as you can see next. So to send a query to the database, like select the name and age from people, we put this into a string, and we're going to call this query string for now. So the way you can think about the DB variable is that it contains other variables and functions. The correct term for this is an object, and the arrow operator, which is how you refer to this, this is like a minus sign and a greater than sign. Right? But it's considered a single operator inside of PHP and a ton of other languages. You put that next to an object, in other words, a variable that contains an object, and then you can do things with it, like over here. So we've taken this query and we want to now pass it to the database. So what we do is we take the database connection that we've got here, which we got by calling new on PDO, and we use the arrow operator to use a function that's part of that called a query. Query is just a way of saying asking a question to the database. And we pass it the string of the query that we want, which is up here, select name and age from people. So to retrieve the data, so once you've done that, the database has gone out and basically done everything it needs to get this data from the database. How much work it actually does ahead of time is a little bit complicated to explain, but you can think of it as the query actually being done. What you need after this point is to get the data out and use it. So we assign the value of this function here that we're calling query to yet another variable, which we're going to call cursor, just because that's kind of like a standard term that you use in database design to refer to the thing that a programming language uses to access the database where the data is sort of temporarily stored. And that too is an object. And one of the functions it has on it is fetch object. So again, we take the variable cursor, we use the arrow operator to say we want to use one of its functions, and we say the function we want to use is fetch object. And that will, the result of that will be data. Okay, the data that you get back here is an object itself, and that's because you can see that we're using fetch object. It makes sense that what it comes back with is an object. And this is the last place where we have to use the arrow operator. We can take the data object that comes back, and we can use the arrow operator and apply the column name, either name or age, to it, and that will return the value that was in that column. But it will do that for just the first row. So how do we get the rest of the rows? Well, as you can see, I've put this in a while loop here. One thing that the fetch object command does, or fetch object function does, is that if there's no data left, it returns false. And that means data will evaluate to false. And then this expression here will exit the loop. So if there's no data in it at all, this loop will actually get skipped altogether. Okay, So that is the mad dash rush through SQL databases and PHP's interface to them. We know that so that we can set up for the idea of talking about one other type of injection attack, the most popular kind of injection attack, and that's an SQL injection. So if you want to follow along with this, you can download a zip file associated with this lecture. I'll be going over the contents of it a little bit here to help you set up. It'll contain PHP files and an SQL script. The PHP files you can put into var/www on your server. And then you want to import the PHP file, or sorry, the SQL file. So to do that, you need to log into AdMiner or AdMiner. If you've forgotten the database password, that's okay. You can log into the web console, which is at port 12320 at your server's IP. You can also get it to it from the main IP address of your server. And then log in as root, which hopefully you remember that password, and run the command mysql_secure_installation. That will take you through a little script and it'll ask you a bunch of questions. One of it will be to, if you want to reset the root password, and you can hit Y, and that will allow you to reset the password. MySQL, actually, once you have root level access to a machine, it's terribly easy to reset the root password. In a lot of cases, there are very few ways that you can configure it to make it difficult. Okay, actually, I've got these images a little mixed up. Once you do that, once you're in AdMiner, you can go to the left-hand side and select Import. And then you want to click the Browse function that'll come up. And then you want to locate your file in your directory system. This is the SQL file. And then you want to click Execute. And that will upload all the things you need for this example to work. All it is a couple of database tables and one user. So let's take a look at this. What we've got is a script that creates a little store. And let's go to, I believe we call store items.php, except I need an E. And there we go. Okay. So what this script is an example of the kind of thing that you might find in an online store, right? It's got a bunch of items in a database, and it displays them on the screen. And the script is there, and you can take a look at it. I'll go over it a little bit at the end of the lecture. But I've also added one line here. And what this does is lets you see the SQL query that we're running, right? So there's a table named items, and you're doing select all from them. Now, this script also has a feature built into it that is search, that allows us to specify a search criteria. So if we type in COR, except it's not %. As you can see, it brings back only one item from our inventory of 2, right? And this is the Corsair DDR4 2400 32 gigabyte DIMM kit, right? And the reason why, because here's what's happening with the select statement, right? Where it's taking, before it was just selecting all from items, now it's adding a where clause, and it says where item name, and then it's using like and this function here. The like function lets you search by something that is similar to, as opposed to something that is equal to. And what it's doing here is it's adding it puts a bracket, a single quote, a %sign, the letter COR, another %sign, and then a single quote and a bracket. So like has to be a string, and the string has to be contained in brackets. So that's why there's a bracket and a single quote here. The % represents match all. So what this does is it looks for any name, any item name that has the letters COR anywhere in it. So it can have COR with something in front of it, COR with something at the end of it, COR in the middle of something. So we can test this by pointing out that if we put the characters ODIM, this still matches this record, right? Because it's matching this part in here. It will also match in something at the beginning, as you recall, it matched COR, and it can also match things at the end. So we can write kit. As you can see, that also matches. Okay, so that's all very useful. But there's some things going on here now because of this that we can use to take advantage of this. So just like in our other examples of using, say, command insertion, what we're going to do here is try and add to the query that's being run to get other information back. And one of the ways you do that, or one of the more common ways, is to use another command, union. So union is an SQL command that joins two queries together. So we could type union select all from items. Now this isn't going to work. I'll explain why in a second. And I'm putting a semicolon at the end here. That's the end statement for an SQL statement. Okay, we got nothing back. Now why? Okay, as you can see, our union statement here was added on the end of inside this like clause. So if we want our union statement to be have the SQL interpreter pay attention to it, we actually it has to be outside of this like clause. But this like clause needs something to close it off, and what it needs is a quote and a bracket. So we can just add that here. It doesn't really need a %sign, but okay. Now we still got nothing because the table name we specified is item, and the actual table name is items. So we'll change that here. And there we go. Now union only returns unique rows. So the fact that we don't see the rows twice because there's one row that comes from the first query, and then the second row comes from the second query, which returns all rows. Okay, so just think about this right now. We have just manipulated the query that this is running. Now, once we have this way of manipulating something in the machine, the first thing we're going to do is use it to do some reconnaissance. So how do we do that? Well, if we wanted to run queries on any other data, we would need access to tables, right? We can't run a query without a table. So what would be an interesting question to ask is, well, is there a query that we can run that tells us what all the tables are? And the fact of the matter, there is. Just about, sorry about that. Just about every system, every database system that exists has a command for doing that. Now, they vary depending on the system that you're using. But here, and so you can always just Google it. But in MySQL, I'm going to put this, and let's just open up Notepad for the moment. I'll put it on screen. Now there's a command that's in MySQL called describe, but it's a little bit harder to manipulate. That can get information about tables. There's also a command called show databases, show tables. Some databases support, but almost every system has an actual query you can run to get the list of tables. And this is it. And you can always Google for it. Or if you're doing an exercise and you can buy something called an operator's guide. An operator's guide is a document that shows you all the major like shortcuts or useful commands in all sorts of operating systems and databases. There's a couple of them that I would kind of sort of recommend. But yeah, so if you're doing this kind of investigation, then that might be a useful thing to have if you're going to have trouble querying things. One of the places you would use it is in a live fire environment when you're doing a red team system. But yeah, so we've got a select statement, we've got table schema, the table name, and the column name. And we're taking this from a table called information schema.columns. That's pretty useful. So we should just be able to drop this right in here, right? We should just be able to union that. Well, you know it's not going to be that easy. Okay, that didn't work. But let's look at our query here. One of the things that's useful to understand is that when we union two queries, they have to have exactly the same number of columns. It doesn't know what to do without that. So items has how many columns? 1, 2, 3, 4. How many columns do we have here? 1, 2, 3. Oh, okay, that's not that useful. So let's look at making a change here. So we can add a column into a select statement just by adding a dummy row or a dummy column, sorry. And I'm just going to put a 0 there as a dummy column. What that does in a select statement is it just creates a fake column with nothing but zeros in it, as if we had queried a database that had a column after row of just zeros. Boom. Okay, so that's pretty useful. You can see we're getting the database information from items, but we're also getting information from this table. Now, you'll notice one thing is that we do have 3 columns here, but the third one is just made up of zeros. So what's going on there? Well, what's happening is, as you can see, column name, which would be a useful piece of information to have, is in position 4 here, which means that it goes in the price column. But the price column is clearly formatted as a numeric, which means under PHP rules, it's going to be evaluated to 0. Okay, so how do we fix that? Well, we can't, at this point in time, we don't really have any access to the code. So one of the things we can do to our query here is we can use another useful SQL command, and that's concat. Concat lets you put 2 columns into 1 column. So we're going to concat table schema, and we're going to also concat a fake column of spaces just so that they look nice. And then we're going to concat that with table name. So that will give us 2 columns, but we need 4, right? So we can add a fake row of zeros here, and for the price, we'll run another fake row of zeros there. Okay, so let's head back here, add this to our union clause instead of what's going on there. And I probably made a mistake. Oh, I didn't put a semicolon at the end. Because if I don't put a semicolon at the end, the percent and bracket gets added from the rest of the like clause, and that ends up causing an error. All right. Well, look at that. Look at all the tables in this database. All right. So we know this place is called Ontario Computers. So let's look through this data. There's a lot of it here, as you can see. So let's use Control F on our browser to search through this. And I'm going to look for something called Ontario. Ah, interesting. Remember, we've concatenated here the name of the schema, which means the database name, the table, and then the column. There are 3 tables here. There's our items table, which we can see the data that we're looking at in the catalog. And there's a session table, and there's an authentication table. Huh. So again, part of reconnaissance, let's see what's in some of this stuff. Now that we know that, we can use this to find out some information, and we can use some pretty basic queries now. Like, for example, we can, let's take a look at what's in authentication, right? Authentication has exactly 2 columns. So let's go back here and plan out our query. Well, we can do a select all from, also the capitalization, just so people know, is just some, it does, SQL Server doesn't care, or SQL doesn't care about the capitalization of commands. It does care about capitalization in column names usually. There are some cases where some databases don't. But I just use it as a matter of convenience, and it's easy to identify the difference between columns and commands. So that will give us 2 columns, but we need 4. So let's just add 2 fakes. Whoops, wrong thing. Let's add 2 fakes here. And see what we get. So we're going to take our union statement again. We're just going to add this to it, our semicolon onto the end. It's going to balk at the fact that I used the star operator, I think. So one thing about SQL is that although there is a standard, it isn't necessarily followed quite to the letter. Oh, I'm still getting, oh, what? Okay, for some reason that didn't copy. That's okay. Okay, so now we got username, password, and a couple of zeros. Let's see what happens here. Boom. Hey, look at that. We now have the contents of that table. And there are 2 accounts in the username field, administrator and stock boy. And in the description field, we have the password. This big, long series of digits. Anybody who has been through asset security should know what this is. This is a encrypted hash. And if you want to take a guess, you will eventually learn to recognize these things. But you can guess that, and it wouldn't take that much to figure it out on your own, but that this is an MD5 hash. Now, most of you should remember from asset security that MD5 hashes are what? Strong or weak?
They're weak.
Yeah, super weak. In fact, they're generally considered to be not good candidates for doing passwords of any kind. So There are a multitude of tools on the internet for doing MD5 cracking. You could do them on your own machine, but let's pull up something. Yeah, not there. Yes. All right, we can just search for. All right, let's take this one. And let's just paste that in there. Boom. We now have an administrative password that was cryptographically hashed on a system that we had no prior information about. Now, admittedly, we gave you the indication of what the select statement was, but I mean, this is something that you will over time learn to infer on your own, right? This once you see the use of this parameter here, right, you can start to infer as to what it's actually doing, and you will start to use, you can start to just randomly add things to it, like well, is this something that's just looking for, like, is it looking for a specific thing, or is it looking for anything that's similar to something? If it's something that's similar, you know it has to be an SQL-like clause, right? And you know how those are formatted, so you can add some information. And if it's something that's exact, it's an exact search, then you know it's actually an SQL equals clause, or it's a where clause using an equal sign. So that, again, you know how to specify for that. So now there are definitely ways to fix this, and that is a subject of another course. You can look it up online. Basically, sanitizing parameters is a big deal when it comes to any database application. But the point here is to know exactly what to look for and how to investigate. All right. So that is, I think, all I'm going to cover on this. Let me just go take a look at the lecture again. So this is our search thing. This just steps you through all the stuff that we're talking about in case somebody's looking at this after the fact. How we do the schema, columns, pull this from Ontario passwords, and how to crack it. Okay, so here's the script. It's not that difficult. I mean, standard HTML, some CSS here to format the table rows, the welcome sign. We start a table here. And then we go ahead and connect to the database. We use the standard is set to handle if we have something that's empty. If the search parameter is empty, we just pass nothing back. And if it has something in it, then we use a where clause. We create basically a string that has the where clause, the field name, and the format for the like clause with the search parameter put inside it. There's a better way to write this, by the way. And then we connect to the database. We run our query, and then we just tack on the end the contents of the search screen. So that'll either end with the where clause and the like clause, or it will just have nothing in it, in which case it will bring back everything. Then we put these things into the cursor, and we iterate around. And then all we're doing over here is we're filling those pieces of data into a table row. That's what the TR is for. And then we close it out. So there we go. That's our storeitems.php. And that is how SQL injection generally works. There are a few other ways that SQL injection can work. If you're dealing with an authentication system that is looking to see if you return, like if something matches something else, right? That's looking for a true false. You can add parameters onto the end of it that automatically will return a value. So you can have something like, you can at a clause that says, so select something from the password database where the password is equal to the password we've passed in, or, and so that would be the way it would normally work. And what you could do is tack on to the end of that is the clause or 1 equals 1, right? That will always evaluate to true. And the or clause lets either the criteria in the first parameter or the second parameter. And I'll just give you, I'll write this out just so that it looks something. So if you had a database that had something like this, right? Or this is being pushed in from PHP. I'm not going to bother writing all the PHP, right? And the password is getting hashed. And this is getting, actually, one of the things you could do here, you can do the hashing right in SQL, like this, right? Okay. I will put the PHP stuff in here just to be sure, just to be clear. So if you had a query like this and you executed that, one of the things you could pass in the parameter is the password could be equal to something like, could be equal to whatever you type in, right? And then you can put in, there actually should be single quotes around there, but I'm not going to worry about that. So you could pass in a single quote and then a bracket for the MD5. And then you could pass in or 1 equals 1. And if this test was being evaluated, this would then match always, and it would get us, it would register a result. Now, this isn't controlling which username it matches to, and that's something you can fool around with a little bit more. But the idea of adding a or clause that always evaluates true is the principle here. Okay, so that's just about all the time we have for today. There will be another lecture up about broken authentication. I should get it up for sure tomorrow morning. I've got most of it done. I've got some demos where we'll be doing credential stuffing as well as attacks on session keys, and that will round out item 2 in the OWASP Top 10, and then we'll be on to what's part 3? Can't remember offhand, but we'll be on sensitive. Actually, we won't be on sensitive data exposure. We'll be using XML external entities. So we'll be doing CSRF and a few other things like that, which have some pretty interesting outcomes. And it's going to require me to write a bit more sophisticated applications. Okay, so if everybody's cool, I would recommend that you give the quiz a try. The quiz will be open until I think Saturday. I gave you extra time because I was late on that stuff. But yeah, if you haven't watched the video, that make sure there's one video that covers 2 more modules. And yeah, after that, we're moving forward. So just to give you an idea of where we're eventually heading is at the close to the end of this, your final project will be that I will provide each one of you with a VM. The VM will contain a turnkey Linux install that you don't have the password to, and but I will give you a URL for a web application, and what you're going to have to do is do an analysis on it, and you're going to use all these techniques that I'm showing you now to find various problems, and what you're going to do is document them all as you do them and then write a report. Okay, so it should be pretty interesting. I'm just going to turn off recording now.